Last week we talked about the strength, weak ties and strong ties and bridges. Today we will talk how we can make them, these are like, on and off things like weak or strong. There is nothing in between. It's like black and white. So immediately one thinks about, would there be some floating number instead of a Boolean? Well, this is my thinking as well. Like when you do programming, you immediately think about, okay, this is Boolean, 0 or 1, black and white. How can I make it a floating point or a double number that can be small steps of variation, even, or an integer instead of a Boolean? Is it possible? So we will look at that, how it is possible first, and then we will hopefully we will take a look at betweenness centrality. So one of the important metrics that very widely used in network analysis. So we said we talked about this study of Granovetter in 1973. He says between people, but this can be generalized like in many other things. The edges can have some attributes. The friendship between people some of them are real friendship, and some of them are like acquaintances. You know the person, but you're not really very strong with it. His theory was, if there are two people that you have strong ties with, that means that you're really good friends. It's very possible that they will one day be meeting, then therefore having an acquaintance. So forming a weak tie. So he talked about the triadic closure, and it said if there are two strong ties between my two nodes, then there should be at least a weak tie between them. So we talked about that. So, but that was like an on and off. Well, actually not on and off. It is 0, 1, or 2. Like 0 being no tie, no edge, and or maybe you can say 0 or 1 because if you have an edge, then it is 0 or 1. If it is weak tie or a strong tie, then we have to take a look at that. And this information is coming from, of course, being a strong tie or a weak tie is coming from the field that we are looking at. It is not. When you look at the network, it is not something that you can comment about it. It is the information that you're collecting. That information is coming from the field, like anything, I don't know, that any study whatever study that you're doing, either maybe you come up with something like within the Turkish Airlines map or Lufthansa map, you look at that and you had an idea that between these edges, I can come up with something similar. There is a strong tie or a weak tie depending on number of flights. If number of flights above this threshold, then I call it a strong tie. If it is not, it's a weak tie. Okay, this information is coming from the field. But what Granovetter is telling, that the extra thing that he is telling, that there is a strong triadic closure. That means for humans, there is two strong ties, that means very good friendship between two people, then most probably they're going to have a weak tie, at least a weak tie. So again, from the field, I can get some data, and I can test that if this is true or not. So that was what we looked at last week. And we said also, we took a look, we first of all mentioned about the bridges. A bridge is something that if you connecting two nodes, it's an edge, of course. If we take off this edge, these two nodes will only be able to be connected with a span of more than two. That means that if I lift this, for example, in this case between A and B, if I lift it, it will take 1, 2, 3, 4 steps to reconnect them. Well, they are already connected, but if I remove this, the connection between A and B, the path between A and B, will be 4 steps. So that's more than 2, then this is a bridge. And we said something about, well, if the strong triadic closure is true, then it must also be true that bridges are weak ties. Because if they were to be strong ties, then there should be, like these are strong ties as well, there should be another link between, for example, between B and E. And this is against the rule that this is being a bridge. Either if it is a strong tie, this is not a bridge. Because if I have a strong tie here, I have a strong tie here, and that demands that there is a weak tie here. But in order for this to be a bridge, there had to be, if I lift this, there had to be more than 2 steps to connect A and B. But since I have this, I formed this because this is a weak tie now. Since I lift this, I have this, and it is 1 step. So it is against the definition of the bridge. But there is again, this is either a bridge or not. It is again a 0 or 1 distinction between being a bridge or not being a bridge. We first talked about these are edge attributes. We first talked about an edge attribute. We said strong or weak tie. So this is a strong edge or a weak edge. That's binary. Then we are talking about being a bridge or not being a bridge. That's again binary. So today we will talk about how we can turn them into some values that are not binary, a floating point or an integer, whatever it is. So, well, the first step is, of course, about the weak and strong ties. Edges, the attributes of edges could be anything, of course. And it is, I said, it is coming from the field. That information is coming from the field. Well, this information, on the other hand, being a bridge or not, we decide by looking at the map itself. So we only look at the network, and this is how we decide if it is a bridge or if it is not a bridge. We know that this is not a bridge. We know that this is not a bridge or this or that. But we know that this is a bridge. So we don't look at the field data. We look at the network itself in order to understand if it is bridge or not. So this is a different story. But the easy part, or maybe the easy part is when we look at the data the field, the subject matter that you're looking into, being strong or weak is coming from there. So Granovetter was looking at the strength in terms of being a good friend. In that case, he says this is a strong tie, or just an acquaintance. In that case, that's being a weak tie. But he could have come up with something else. Actually, I forgot to show you from last week's. This is again our book, you remember, that's available on the web. You probably downloaded all the chapters. Chapter 3, you're still on chapter 3. This is a different study. In this case, they marked the attributes, not binary, but there are a number of, like we will see, there are a number of cases for each edge they have. So they looked at Facebook friendships, and well, of course, along the way, I do understand that. I don't use Facebook, but I do understand that you get some requests to be a friend, but a Facebook friend is not really a friend. Some of the friends on your Facebook account are your real friends. Some of them are not. It is like somebody is requesting to be a friend of yours, and it is not so nice to reject, even though you may wait a little bit. I think that's an indication that you're sending a request to someone, probably, and if it is delayed, then you realize, okay, this is how he or she is thinking about me. But if he or she is immediately accepting your friendship, that's an indication as well, probably. So, in this case, they have to come up with some data, some real basis about how to judge between really being a friend or not being a friend. They looked at first they looked at all of the friends, and then they looked at several cases. For example, if there is a two-way communication between these people, like myself and one of my friends. If we have mutual communication, I'm sending a message and receiving a message from that person. That's another type of edge. Or if I'm only sending some messages but not receiving anything, that's a different case. Or nothing at all. No communication is happening. So as I said, it all depends on the type of communication, or it all depends on the data, the field study that you're doing. You're collecting data, and according to that, there might be some integer values, or there might be some floating point, like between 0 and 1, attributes for the edge, depending on our case. It can be, for example, we might be looking at the emails, number of email interactions between people. In that case, that could be the number of emails. And it may also be, for example, I have an example here. Like this, we did it on Istanbul when we were doing this study with our friends. The bus stops and bus lines in Istanbul. We look at the capacity, the number of services for each bus line, we look at the capacity and the frequency. So that's becoming the attribute for the edge. And we are converting it into the thickness of the lines. As you see, thickness is different. There can, of course, be multiple values or attributes about the edges. For example, in this case, these gray lines are buses. These blue lines are ferries. And these green lines are underground, metro. So that's something you can do. You can have multiple values for edges. Of course, we have to deal with them afterwards. And for our case, you remember when we were collecting data for the airlines, we did collect the number of flights per week. Right? I don't know if you did it as well, but when I looked at it, when I was looking and getting the data from the timetable, it was very immediately available, so I recorded it as well. Okay? So that's the strength for me for this edge. So this one easy. So it's coming from the field. It's coming from the field data. Now I will show you a short. I will show you how to get this data into Cytoscape first of all. All right, because that data was available. We didn't use it. We will start to use it. We will make the Cytoscape map that we created a little more appealing. We first made it, we used the forced layout to make it look better. Now we were beginning to make it look even better. Because now we will get for example, we will use Germany or France or Turkey. We will get the capacity values for the edges into our network, and we will use it, for example, to change the thickness of the edges. It's very easy, straightforward. If you want to do it with me, you can, but only two as notebooks. Anyway, you can, of course, think about bringing your notebooks during the class, if you like to. All right, so you would remember that I was importing this information from an Excel file. And let me show you the Excel file as well to do this. Yeah. Okay, it was something like that. I have the source node and the target node, and this was the capacity. And that was, you remember that there was no so this was the information I had. Okay, so I go to import and import network from table. Select the file. All right, here I got it. So over here here I say my column 1 is my source interaction. I can't do anything with the interaction type. My target interaction is column 2. And over here, if I click on this column, it turns blue. Columns in blue will be loaded as edge attributes. All right, so I'm going to be having these values as edge attributes. Here it is. So you will remember that I was using force directed layout. Okay. So it was also possible to, I just try to remind you some of the features that we were having over here. You see, I can make this a little bit farther away, and I can zoom out. Okay, this is nice. So, but now I have, for every edge, I have this capacity information. How can I see it? If I click on one of these, if I pull it up a little bit, and I select the Edge attribute browser, it's now on the node attribute browser. Alright, and then select all attributes. If I press this one, you see column number 3 is 12. So this is 12. If I select a number of them, you will see that these are all different. So it's also possible to visualize this. It's sometimes nice to be able to see it, to really get an understanding about the picture, how it looks like. So how we do it is just like that. So there is something called a WizMapper over here. If I go to edge line width, double click on this one, and I select column 3, and then I have to decide on the mapping type. There are several mapping types over here. There's a continuous mapper, a pass-through mapper, and a discrete mapper. This is a continuous mapper. If this is a number, then use a continuous mapper. If it is not a number, for example, if it was just like this previous example, if it was like a ferry, bus, or metro, so there are two different values for example, F, B, and M for ferry, metro, and bus. Then you can use the discrete mapper. So you discretely map these things into some different thicknesses or colors. So when I use this one, wow, okay, it was terrible actually.